Greetings. Welcome to Statistics. Statistics touches our lives probably more than any other mathematical form. There isn't a section of the newspaper that doesn't contain some statistical kind of information. There isn't an area of the TV news, sports, weather that doesn't involve some kind of statistical idea from time to time. And so we get it. We're hit by statistics all the time, and it may occur to us to wonder where this information comes from. For example, if we're talking about a survey of people favoring this idea or disfavoring that idea, or what percentage of people either smoke or don't smoke, and different things like that, how do they find out that information? See, and that leads us to the notion, they're kind of like two areas of statistics. Two categories. We can make calculations like batting averages, for example, on the sports page, based upon an entire amount of information, all the information about a batting average. It's a very simple idea. Take the number of times at bat and make a calculation according to the number of hits by comparison, and we have a certain statistic called batting average. Well, what about decisions that are made or information that we gather with incomplete information? The opinion poll idea, for example. We can't very well go ask everybody in the country a question and get an answer and say, we know with great certainty that 20% of Americans favor so-and-so. You see, so we have to make a decision like that or come to that conclusion based upon incomplete information. And that's part of what statistics is all about. Here's a definition of statistics. It is the study of how to collect, organize, analyze, and interpret numerical information from data. Now, each of these categories could be a study unto itself, but this is what statistics is all about. And we'll touch on all of these areas from time to time. And you might be thinking, well, numerical information from data. It's kind of like, well, gee whiz, I thought information and data meant the same thing. Well, it does, but the numerical information from this overall body of information, you see, is what we're talking about in performing the tasks here involved in statistics. Now, data itself then can be quantitative or numerical in nature and qualitative. And so quantitative refers to numerical measurement of data. Qualitative refers to non-numerical information that's made by observation, information like the color of hair or colors of cars or something of that nature. So made by observation. We're going to talk about a vocabulary associated with statistics. One major topic or word that we talk about often in statistics is the notion of population. Population refers to all of the measurements or observations of interest in some problem that we're talking about. Now, when we think about population, often we think about people and the people within a country or a state or a classroom or whatever as a population. Well, population refers to something a little bit different when we're talking about statistics. Actually, we're talking about measurements generally when we talk about population. So if we're talking about average height in a classroom, it would be the height of all of the people that are within a particular classroom. You see, those different height measurements would be the population. And it is from that population and those measurements that we can find the average of all of those. And now notice I'm in thinking about average height, I can think in terms of a small population of heights that are within a classroom. I can think of a much broader population of these heights within a state and an even broader population of heights within a nation. And this kind of brings us to the notion of the need to use a sampling to help us with this decision-making process. We'll get to the notion of sample in just a second. Now, notice that when we talk about height here, we're talking about a quantitative kind of measurement. And a qualitative kind of population would be the percent of white cars. You see, it's just made by observation. if we're going to make this kind of calculation. Okay, so population. Now, as the population of interest grows larger and larger, it becomes more and more necessary to, instead of using all of the items within the population to make our calculation, we could use a sample. And a sample is just a subset of the population. So it is part of the population. And it's important when making this kind of, or taking a sample from a population, to make sure that the sample is random. And an entire study in statistics, it can be made of what is a truly random sample and what is not. If we're talking, for example, about, there's an example that I read in the text about a certain study that was made in a pineapple field. And let's say that the pineapple field is a matter of 100 acres of pineapples. And we want to know the average weight of the pineapples in the field. Well, we can't very easily go through and weigh every pineapple in 100 acres of pineapples. So we would take a sample. Now, for the sample to be random, do we take the first 5 pineapples that we see? No, that wouldn't be very random. What we would do is we would take, perhaps, this is one way we might think about it, is we might think, okay, if this is a diagram of the 100 acres of pineapples, then what we might do is take a pineapple over here and another one here and one here and so on, you see, and just randomly select pineapples from throughout this field of pineapples, select 100 of them, and then we have a relatively random kind of sample. So samples are parts of populations. Random samples are the best kinds of samples to take, and samples are used to infer conclusions about populations. Now, the bad news is that those conclusions are uncertain. There's uncertainty built in because we're sort of extrapolating or saying that something having to do with the entire population, a decision that we're making about an entire population, is based upon some kind of sample which is not the entire population. So we can't be absolutely certain that our opinion about that is true. You know, if we want to know the nation's opinion about a certain topic, and we say 40% of Americans feel this way about that topic, then how certain are we that exactly 40% feel that way, you see? If we take a sample of 5 people, and they're 5 of your friends or 5 of my friends, how certain can we be that the entire nation feels that same way? I don't think we can be very certain at all. If we take a sample that's 100 people, can we be a little more certain? Well, maybe so. How about 1,000? How about 10,000? How many does it take to where we have great certainty? Well, okay, the point is that we're uncertain then about that inference that we're making. So the conclusions are uncertain. That's the bad news. The good news is that that uncertainty is measurable. And we can measure it using probability. And we say something like, we are, because of the size of our sample, that we are 95% certain that 40% of the people feel this way, or something of that nature. If we're talking about the weights of those pineapples, then, you know, the population that we're talking about is the weights of all of the pineapples in the field. That's the entire population. The sample would be the weights of those pineapples which we selected, those 100 or 1,500, I don't know what, but from that sample. And the sample is the weights of the ones that we selected. Okay, and from that we say something like, we're 95% sure that the weights of all of the pineapples, the average weight of all of these pineapples would be, 2.5 pounds, give or take a couple of ounces, you know, something like that. So there's a probability associated with the inference that we're making. There are a number of levels of measurement that we want to talk about, and there are actually 4 of them, and we want to be able to put them into categories. The lowest level is the nominal level. The word nominal means in name only. Now, this level of measurement is not intended for any kind of numerical calculation. I mean, if we're talking about items at a nominal level, might be that we are choosing out of the population of the names of all of the states in the United States, we're choosing a sample of 5 names of states from that group. Well, what does this tell us? I mean, this is just a group of names only. You see, if we're talking about the names of all of the students in a class, and we choose a sampling of 6 or 7 names of the students, what does that tell us? Well, it doesn't give us very much. It's just a sampling, it's just a group that is at the nominal level of measurement in name only. Ordinal level. Now, at this level of measurement, the data may be arranged in order. So we can put an order on it, but the differences are meaningless. That's kind of like taking looking in the newspaper and picking out a restaurant or evaluating restaurants according to some kind of star rating. Okay, 1 star, 2 stars, 3 stars, 4 stars. You might get a fairly broad feeling about whether or not you want to go to a restaurant if it has 2 stars versus 3. But gee whiz, I mean, you're putting those restaurants in some kind of order, but there are so many factors involved in your dining experience that are not in that star rating that you just really are out on a limb trying to make a decision about that. Another idea is the notion of ranking students within a class. You know, a graduation ranking, for example. Somebody graduates 5th in a class, somebody's 10th, somebody's 15th, somebody's 20th. Okay, so we put them in order. But what's that ranking all about? Do we know that the one ranked 5th, the one ranked 10th, gee, one student is twice as smart as another one? No, of course not. We can't make that kind of conclusion at all. And the difference between them in terms of rank may be almost 0 in terms of grade point average. There might be 20 students that have exactly the same grade point average, or pretty close to it. You see, and then a difference in rank somewhere down the scale might have a much bigger difference in grade point average to give rise to the rank. You see, so you're able to put the information in some kind of order, but the information is relatively meaningless. Okay, that's what the ordinal level is all about. Interval level. Now, at the interval level, we contain the good aspects about the ordinal level. That is, we have the order idea going for us, but we have differences that are meaningful. Now, the shortcoming of the interval level is that the information may not have a 0 starting point, and so ratios are meaningless. Now, I'll tell you about what this means in just a second, but an example of information at the interval level would be temperature in Celsius or Fahrenheit. Now, I mentioned that there's no 0 starting point. Now, temperature is a measurement of heat, or let's think about it like that. It's a measurement of heat. And does 0 mean there is no heat? No. The 0 on the Celsius and Fahrenheit scales do not mean no heat. It means a certain amount of heat up to that point. It's just a reference point on both scales. So we can't say, and some people tend to want to do this, that if we're thinking about 50 degrees Fahrenheit and 100 degrees Fahrenheit, is 100 degrees twice as hot as 50 degrees? Well, we often use that idea, but it's not twice as much heat. If we're measuring heat, it's not twice as much heat because we don't have a 0 starting point on the scale. You see, now in Kelvin we do, but not in Celsius or Fahrenheit. Another example of the interval level would be dates. You know, dates of discoveries, let's say. So the so-and-so was discovered in 1908 and something else, some other product or whatever was discovered in 1925 and another was discovered in 1937. What does this mean? Well, you see there's no sort of zero starting point for dates because time, you see at intervals of time like that associated with dates, there's no zero involved in that. Now, if we're talking about the elapsed time, then we can talk about zero elapsed time, and then we start the space shuttle at this point in time and we keep going, and then we can talk about doubling and halving and all that kind of stuff of time. But if we have no zero, then we can't talk about doubling and halving. You see, we have no ratios involved unless we have a zero starting point, sort of. So that's the idea of interval, is that we have order and the differences are meaningful to us, but we don't have a zero starting point, so we can't talk about doubling and halving and such things, so ratios are meaningless. Now, with the ratio level, the next level, the highest level, it includes all of these ideas. A zero starting point is involved, so ratios then have great meaning to us. Things like, well, we used the temperature idea a little while ago, and scientists like to use temperature Kelvin so that when they say twice as hot, they really mean twice as hot, twice as much heat, you see, if we have a zero starting point. And distances and time, you see, we're talking elapsed time, not dates in time. Elapsed time is important. Money might fall into this category because you double the amount of money, you can have zero money, you see. And you can think about doubling and halving money. So money falls into the category of this ratio level, as well as distances, and we already talked about time. Now, before we go with this section, I want to encourage you to read the information in your textbook in this, particularly in this introductory kind of section. You know, we haven't done any calculating yet. We've just talked about what statistics is and some of the things that we're going to be studying and the importance of certain issues and so forth. And to get a better grip on the importance of these items, look at the examples in your textbook. Read some of the content. You'll get a great deal out of putting in that time, and it's a relatively easy read.